65 million years ago, a tiny sphere, no bigger than a grain of sand, drifts down through the ancient skies and settles into the mud. It is perfectly round, forged from rare metals that do not belong together in nature, and it carries the unmistakable fingerprint of a nuclear detonation. Fast forward to today, and geologists pull that same sphere from a layer of rock that predates every human footstep, every pyramid, every smartphone. The metals inside match exactly the fallout from the bombs we dropped in the 1940s and 50s. The pattern is identical, down to the isotopic ratios that only form under the crushing heat of an atomic blast. But 65 million years before Hiroshima, before the first campfire, before the first fish crawled onto land, something on this planet split the atom and left its calling card in the dirt. Pause for a second and let that sink in. We have always told ourselves we are the first to harness fire, the first to build cities, the first to look up and wonder. Yet here is a microscopic bomb fragment older than the dinosaurs that did not survive the asteroid. It is not a fossil. It is not a bone. It is engineered debris, scattered across the globe in a thin, invisible line that circles the planet like a scar. Scientists call it the iridium layer when they talk about the rock that ended the age of reptiles. They never mention the titanium microspheres riding shotgun inside it, spheres that scream high-temperature industrial process, spheres that should not exist. Picture the scene. The impact crater in Mexico is still smoking. Tsunamis the size of mountains sweep the continents clean. Forests ignite from horizon to horizon. And somewhere in that chaos, a civilization that had already mastered nuclear fire watches the sky fall. Did they see the asteroid coming? Did they try to stop it? Or did they trigger something worse, a chain reaction that lit up the atmosphere and painted the ground with these impossible grains? We do not know. All we have is the sphere, silent and perfect, waiting 200,000 generations for us to dig it up and ask the question no one wants to answer. What if the bomb went off long before we were here to light the fuse? That single grain of fallout is the crack in the story we tell ourselves about being alone at the top of the ladder. It is the whisper that says, maybe the ladder has been climbed before. Maybe the rungs are worn smooth by hands that are not ours. Maybe the view from the top is not a beginning but an echo. And if one sphere survived, what else is down there? What other fingerprints are pressed into the stone, waiting for the right light to reveal them? Hello there, and welcome to Mystery History for Sleep. I am Mr. H, your companion through the long, quiet hours when the past refuses to stay buried. If a single impossible sphere is enough to keep you listening, imagine what 2 hours of buried secrets can do. Tap that subscribe button and ring the bell so these whispers find you every time the clock strikes deep night. No rush, just a gentle invitation to stay a while longer in the dark with me, because the sphere is only the beginning. 65 million years is a Tuesday afternoon in geological time, and the clock has been ticking a lot longer than that. Somewhere beneath your feet, the planet keeps receipts. And tonight, we are going to read them together, one layer at a time, until the silence starts to speak. 2 billion years ago, when the sky was orange and the oceans were green with bacteria, something extraordinary happened deep under the ground in what is now Gabon, West Africa. Groundwater seeped into cracks in the rock, carrying dissolved uranium. Normally, that uranium would just sit there, decaying slowly over eons, giving off a faint warmth like a dying ember. But in 17 separate spots, spread across a few miles of ancient riverbed, the uranium did something no one expected. It reached critical mass. Not once, not twice, but over and over again for hundreds of thousands of years. The reactions started, ran at a steady 100 kilowatts each, and then shut themselves down without melting the surrounding rock or poisoning the water. 17 natural nuclear reactors, operating like clockwork long before the first multicellular organism even dreamed of existing. Scientists discovered this in 1972 when French miners pulled ore from the Oklo deposit and found the uranium was already spent. Natural uranium straight from the ground should contain about 0.72% uranium-235, the isotope that fissions easily. Anything above 3% can sustain a chain reaction if moderated properly. At Oklo, the leftover uranium measured as low as 0.3% in some seams. meaning the missing fuel had been burned away in controlled bursts. The waste products told the rest of the story. Fission fragments like cesium, strontium, and neodymium sat exactly where a reactor engineer would expect them, locked in clay barriers that acted like natural containment vessels. Groundwater had flowed in, acted as both coolant and moderator, and then drained away when the reaction slowed, preventing any runaway explosion. It was elegant, self-regulating, and utterly impossible by every rule of random geology. Think about what that means. For a natural reactor to fire up, you need the perfect storm of conditions. The uranium has to be concentrated enough, the water has to be just the right temperature and chemistry, and the geometry of the deposit has to channel neutrons back into the fuel. One site pulling this off would be a miracle. 17 doing it in the same region, starting and stopping in sync, feels engineered. The reactors pulsed on a cycle of about 3 hours wet, 30 hours dry, as seasonal rains raised and lowered the water table. Each pulse produced heat equivalent to a small power plant, enough to warm the surrounding rock and drive chemical reactions that left telltale scars in the minerals. Those scars match the output of modern light water reactors, not some chaotic geological fluke. Skeptics point out that 2 billion years ago, the atmosphere had almost no free oxygen, so uranium stayed dissolved in water far longer than it does today. Rivers could carry it downstream, deposit it in organic-rich deltas, and concentrate it the way gold gathers in placer mines. Over millions of years, bacterial mats might have acted like filters, trapping the heavy metal until pockets reached criticality. Groundwater then moderated the neutrons. Xenon gas built up and poisoned the reaction until it stopped, and the cycle repeated. It is a neat story, and it works on paper, but it requires a chain of coincidences so precise that the odds border on astronomical. 17 separate deposits all hitting the exact 3% threshold within the same few million years, all moderated by the same seasonal water table, all contained by the same clay layers without a single meltdown. Nature can be clever, but this clever? Now, layer on the details that do not fit the natural narrative. The fission products are not scattered randomly. They cluster in neat zones, as if someone managed the fuel burn-up to maximize efficiency. The plutonium-239, which forms during sustained reactions, decayed into uranium-235 at rates that suggest the reactors ran for at least 150,000 years each, far longer than the few thousand years most models predict for accidental criticality. The surrounding rock shows no signs of the massive steam explosions or hydrothermal venting you would expect from uncontrolled boiling. Instead, the heat signatures look deliberate, like someone dialed the power to just below the danger line and held it there for millennia. Imagine the scene 2 billion years ago. The surface is a microbial soup under a methane haze. Continents are drifting, volcanoes belch sulfur, and the moon hangs huge in the sky. Down in the dark, these underground furnaces glow with a steady blue Cherenkov light, moderated by water that tastes faintly of uranium. If something was tending them, it did not need cities or smokestacks. It needed only precision, patience, and a reason to keep the lights on while the world above was still learning how to breathe oxygen. Maybe they were powering deep habitats shielded from the deadly ultraviolet pouring through the ozone-free sky. Maybe they were running experiments on the edge of physics, probing the atom before the atom knew it had edges. Or maybe they were simply surviving, drawing warmth from the heart of the planet while the surface froze in endless volcanic winters. The waste tells its own story. Modern nuclear plants struggle to contain spent fuel for 10,000 years. At Oklo, the actinides stayed put for 2 billion, locked in insoluble minerals that formed around the reaction zones like scar tissue. No groundwater carried the poison away. No earthquakes cracked the vaults. The clay acted as a perfect barrier, swelling when wet to seal every fissure. It is the kind of containment engineers dream about and rarely achieve. Random geology does not build fail-safes this elegant. Critics argue the reactors were a one-time quirk, a snapshot of conditions that vanished when oxygen levels rose and uranium became insoluble. Fair enough, but the isotopic fingerprints keep turning up elsewhere. Traces of similar burn-up appear in uranium deposits in Australia, Canada, and Kazakhstan, all dated to the same narrow window 2 billion years ago. The reactions are fainter, more scattered, but the ratios match. Either the planet hit the nuclear lottery 17 times in Gabon and sprinkled echoes across 3 continents, or something was managing the fuel cycle on a global scale. Step back and the picture gets stranger. 2 billion years ago falls right in the middle of the Great Oxidation Event, when cyanobacteria first pumped enough oxygen into the air to poison most anaerobic life. The timing is suspicious. Nuclear reactions produce oxygen as a byproduct when water splits under neutron bombardment. Could the reactors have been deliberate oxygen factories, kick-starting the atmosphere change that would eventually make complex life possible? Or were they a desperate side effect, a civilization fighting to survive the very poison they were creating? The waste heat alone would have warmed local groundwater, creating hot springs that might have sheltered the first oxygen-tolerant microbes. The reactors could have been incubators, not accidents. We will never find the control rods or the turbines. Any metal would have rusted to dust, any concrete dissolved into limestone. But the bones of the operation remain. The depleted uranium, the fission products, the containment clay. They are the reactor equivalent of a fossilized footprint, a negative space where intelligence once stood. And the footprint is huge. 17 reactors running for hundreds of millennia represent more energy than all human nuclear plants have produced in 70 years. Someone, or something, was using power on a scale that dwarfs our own, back when the most advanced life form was a slime mat. The Oklo Enigma is not just about ancient atoms. It is about what the planet remembers and what it forgets. 2 billion years of erosion, subduction, and rebirth have erased every surface trace. But the underground ledger is harder to balance. The reactors kept perfect records in the only language that lasts: isotopes. And those records say the fire was lit long before we were here to strike the match. Tell me, as that underground glow fades in your mind, where are you listening from right now? A quiet apartment in Tokyo, the hum of a subway train in New York, or maybe a porch swing under a wide Texas sky? And what time does the clock show where you are 3 in the morning with the world asleep, or late afternoon with sunlight slanting through the blinds? Let it drift in the comments if the mood strikes. These old fires feel warmer when we share the hour. Picture a drill ship bobbing in the Southern Ocean, miles from the nearest land, boring a hole straight through 2 miles of water and another mile of sediment. The core comes up in a long plastic tube, striped like a candy cane with layers of mud that have not seen daylight since before the first dinosaur took its first step. Back in the lab, a technician slices the tube open, and the air smells like ancient sea and faint rot. They run the samples through a mass spectrometer, looking for the usual suspects: carbon dioxide from volcanoes, methane from thawing permafrost, the slow breath of a planet cycling its gases. What they find instead is a spike so sharp it looks like a knife cut in the data. Carbon dioxide jumps 300 parts per million in what amounts to a geological heartbeat, then lingers for a few thousand years before dropping back to baseline. The isotope ratio is all wrong for natural sources. It screams burned hydrocarbons, the same fingerprint we leave when we crank up a coal plant or floor a gasoline engine. Except this spike happened 252 million years ago, right at the line where 96% of all ocean life vanished in the Permian extinction. That is the whisper. Not a roar, not a bang, but a quiet exhale of ancient industry caught in the ice and mud. It shows up again and again, like a recurring dream the planet cannot shake. 145 million years ago, another pulse during the Jurassic, when the supercontinent Pangaea was cracking apart and the first birds were testing the air. 66 million years ago, layered right on top of the iridium from the dinosaur-killing asteroid, a carbon surge that looks suspiciously like someone was burning oil to fight the cold of nuclear winter, and smaller echoes in between, faint but unmistakable, every few tens of millions of years. Each time the pattern is the same: a sudden flood of light carbon, the kind locked in coal and petroleum for hundreds of millions of years, followed by a plateau of elevated greenhouse gases, then a collapse back to normal. No volcano does that. No swamp fire. No comet. Only organized combustion on a planetary scale. Drill into the Greenland ice sheet, and the story repeats in frozen bubbles. The ice traps air from the moment it falls as snow, sealing it like a time capsule. Go down 800,000 feet of core, and the bubbles pop with the same tail. Carbon dioxide climbs fast, methane tags along, and the isotopes point to fossil fuels every time. The spikes are too clean, too synchronized across both poles. Natural methane comes from wetlands or cattle. It carries a heavier carbon, 13 signature. This methane is light, stripped of the extra neutron the way refinery crackers strip it from crude. The warming that follows is brutal but brief in geological terms, a fever that breaks after a few millennia. Ecosystems crash, oceans acidify, and then the air clears as if someone turned off the tap. Ocean sediments tell the same secret in a different dialect. Foraminifera, tiny shelled creatures that rain to the seafloor when they die, build their homes from carbon dissolved in the water. When the ocean turns sour from excess carbon dioxide, their shells thin out or dissolve entirely. The cores show bands where the forams vanish altogether, sandwiched between layers thick with their cousins. Above and below those dead zones, the carbon isotopes shift in lockstep with the ice records. It is a global heartbeat, pulsing through water, air, and rock, and the rhythm is artificial. What could burn that much ancient carbon without leaving smokestacks or slag heaps? The scale is staggering. The Permian spike alone matches the carbon release from combusting every known reserve of coal, oil, and gas on Earth today, all in the span of a few thousand years. That is not a fleet of cars or a few power plants. That is a civilization running on planetary infrastructure, pipelines threading continents, refineries the size of cities, engines humming in the dark. Yet the surface is scrubbed clean. No ruins, no roads, just the whisper in the chemistry. One theory floats the idea of massive peat fires ignited by lightning or volcanoes, smouldering for centuries and pumping carbon into the sky. But peat burns dirty, leaving heavy isotopes and soot layers we do not see. Another suggests methane clathrates thawing from the seafloor in a chain reaction. Possible, but the releases are sloppy, spread over tens of thousands of years, not the knife-edge precision in the records. The whispers are too tidy, too deliberate. They look managed. Zoom out, and the pattern forms a cycle. Every spike lines up with a mass extinction or a major reorganization of life. The end Permian event, the worst die-off in history, rides the biggest carbon wave. The Triassic-Jurassic boundary, where 76% of species blinked out, sits on another. Even the Cretaceous-Paleogene extinction, the one we blame on the asteroid, has a carbon kicker that starts before the impact, as if someone was already stressing the system. It is almost as if the planet hits a reset button every time the atmosphere gets too thick with exhaust. The whispers get louder when you layer in the metals. Lead, copper, and zinc spike alongside the carbon in the same narrow bands. Smelting ore leaves those traces, not volcanoes. The concentrations are low but global, dusted across ice caps and deep-sea oozes like fallout from a world that ran on furnaces. And in a few cores, rare earth elements appear in ratios that match catalytic converters or battery chemistry, elements that do not concentrate naturally at those levels. Imagine the world during one of these pulses, continents shrouded in haze, oceans turning to vinegar, skies the color of rust. Underground bunkers or floating platforms keep the lights on, burning the last dregs of ancient sunlight trapped in fossil beds. Or maybe the burning is intentional, a desperate geoengineering hack to warm a cooling planet or cook off a toxic atmosphere. The carbon plateau lasts long enough for adaptation, short enough to avoid Venus-style runaway. Then the fuel runs dry, the factories go dark, and the survivors, if any, learn to live small again. The whispers fade, but they never fully vanish. Each cycle leaves a scar in the record, a thin black line in the rock where the world held its breath. And every time, life claws its way back, simpler, hungrier, unaware of the ghosts in the greenhouse. Until the next whisper starts, and the cycle spins again. We are living in one of those plateaus right now. Our carbon is climbing the same curve, our isotopes matching the ancient ones note for note. The question is not whether the whisper is real, it is whether we are the echo or the source. and how long our plateau will last before the air clears and the next layer buries us. Buried under the red sands of the Karoo Basin in South Africa lies a layer of shale no thicker than your thumb, baked hard during the hottest chapter in Earth's fever dream, the Permian period, 252 million years ago. Paleontologists hunt here for the bones of therapsids, those mammal-like reptiles that teetered on the edge of becoming us. But in 2021, a team from the University of Cape Town was not looking for fossils. They were chasing microfossils, tiny pollen grains and spores that record the death throes of ancient forests. What they pulled from the sieve was not pollen. It was a fleck of something glossy, iridescent under the microscope, a shard no longer than a red blood cell yet stubbornly refusing to dissolve in acid, heat, or ultraviolet light. The lab ran it through every test in the book: Fourier, transform infrared spectroscopy, gas chromatography, electron microscopy. The verdict came back unanimous and impossible. The fleck was a synthetic polymer, a chain of carbon and hydrogen engineered for durability, with a molecular backbone that outperformed anything DuPont has ever patented. That single shard was the first. Once the team knew what to look for, the floodgates opened. Core samples from the Beaufort group, the same rocks that entomb the last Gorgonopsids, yielded hundreds more. Some were filaments, others beads, a few twisted into microscopic fibers that looked suspiciously like woven mesh. The colors varied: translucent white, smoky gray, even a faint blue tint that fluoresced under black light. Distribution was the real kicker. The particles appeared in discrete horizons, thin bands separated by millions of years of sterile sediment. One band dated to 252 million years ago, right at the peak of the Great Dying. Another popped up 190 million years later in the early Jurassic, then vanished again. A third cluster surfaced in late Cretaceous muds, 68 million years old, just before the asteroid turned the lights out on the dinosaurs. Each band carried the same chemical signature, polyethylene, like chains with side branches that enhanced tensile strength and resistance to microbial attack. In plain English, someone was mass-producing plastic on an industrial scale, long before the first tree fern unfurled its fronds. The preservation defied logic. Modern plastics degrade in sunlight within decades, crumble in soil within centuries. Yet these Permian fragments sat unchanged through 250 million summers, buried under kilometers of rock, squeezed by pressures that should have turned them to graphene dust. The only explanation the chemists could muster was intentional design. The polymers incorporated stabilizers, antioxidants, UV blockers, even self-healing crosslinks that modern engineers are still trying to perfect. One sample contained a repeating unit that mimicked the structure of Kevlar, a fiber we invented in the 1960s for bulletproof vests. The Permian version was finer, more uniform, and woven into mats that suggested filtration systems or protective coatings. Another shard revealed embedded nanoparticles of titanium dioxide, the exact formulation used today in self-cleaning surfaces. Whoever cooked this stuff up was not throwing together backyard experiments. They were running factories with quality control that would make a Fortune 500 company blush. Global confirmation came fast and furious. Deep-sea drills off the coast of Australia punched into Permian oozes and hit the same polymer bands. Antarctic ice cores, usually pristine archives of atmospheric gases, coughed up microplastics trapped in bubbles that formed before the continent froze over. Even the remote Siberian traps, those flood basalts that belched the carbon for the end Permian apocalypse, preserved plastic residues fused into the lava flows. The distribution painted a picture of planetary saturation. Winds carried the particles into every corner, oceans circulated them through every current, and geology folded them into every new layer of rock. It was the ultimate littering, a civilization's trash outlasting its monuments by a factor of 1,000,000. Scale it up, and the numbers go haywire. To blanket the planet in detectable microplastics requires production volumes in the billions of tons. That means extrusion lines longer than highways, chemical plants chewing through petroleum feedstocks at rates that would drain the Permian basins dry in a geological eye blink. The energy demand alone staggers the imagination. refining the hydrocarbons, polymerizing the chains, pelletizing, shipping, molding. It all runs on heat, lots of it. Tie that to the carbon whispers we heard earlier, and the pieces snap together. The same hands that burned the fossil fuels were spinning them into indestructible wrappers, bottles, gears, and fabrics. The Permian was not just hot, it was wrapped in plastic. What were they using it for? The fragments offer clues but no manuals. Some beads are perfectly spherical, ideal for bearings or ball valves in machinery that needed to run without lubrication in harsh environments. Others form hollow tubes, lightweight yet crush-proof, the kind of structural elements you would use in aircraft or submersibles. A few shards show embossed patterns, grids, hexagons, even what looks like circuit traces hinting at flexible electronics or smart textiles. One particularly wild sample from the Karoo contained a polymer laced with carbon nanotubes, a material we are still struggling to produce at scale in 2024. The nanotubes aligned themselves in perfect arrays, suggesting the plastic was not just a container, but a functional component, perhaps a solar film or a data storage medium. Degradation resistance points to a purpose beyond convenience. These were not disposable bags fluttering in the wind. They were engineered to last, to survive floods, fires, and freezes. Imagine underground vaults lined with plastic sheeting to keep out moisture, or ocean platforms buoyed by foam that would never sink. Spacecraft hulls, if they had them, would need materials that shrugged off cosmic rays and micrometeorites. The Permian polymers fit the bill, and then some. They incorporated flame retardants that quenched oxygen radicals, biocides that poisoned any microbe bold enough to nibble, and photostabilizers that laughed at ultraviolet bombardment. This was survival gear for a world on the brink. The bands end as abruptly as they begin. After each plastic horizon, the particles vanish for millions of years, only to reappear in the next pulse. It is as if the factories powered down, the production lines went cold, and the knowledge scattered to the winds. Survivors, if any, reverted to biodegradable materials, wood, bone, clay that the planet happily recycled. The plastic legacy endured because it was designed to. It became the ultimate time capsule, a message in a bottle that outlasted the ocean. We are writing the next chapter right now. Our oceans swirl with nurdles and ghost nets. Our landfills bulge with yogurt cups and action figures. In a few million years, that mess will compress into a razor-thin band future geologists will call the Plasticine. They will marvel at our crude formulations, our reckless waste, and wonder why we did not learn from the ghosts in the Permian shale. Because those ghosts left us a blueprint. Make it strong, make it smart, make it last. Or do not make it at all. The Permian plastic is not just trash. It is a warning label on the bottle of progress, a reminder that durability cuts both ways. What we build to endure will outlive us, whether we want it to or not. And somewhere in the red rocks of the Karoo, a shard the size of a dust mote waits for the next curious mind to pick it up and ask the question that started this whole journey. If they could wrap the world in plastic 252 million years ago, what else did they wrap it in? And where did it all go? If these indestructible echoes have you lingering a bit longer in the layers, consider hitting subscribe and the bell. It's a quiet way to keep the whispers coming without missing a beat. No rush, just an easy path for the next shard to find you. Deep inside a quartz crystal pulled from a vein in the Canadian Shield, something blinks that should not blink. The crystal is old, 2.8 billion years old, formed when the first continents were just pimples on a molten skin. Under an electron microscope, the surface looks clean, almost boring, until the laser hits it at the right angle. Then the lattice lights up with interference patterns that dance like code. Not random defects, not mineral impurities, but structured voids, tiny bubbles of empty space arranged in repeating sequences. The pattern repeats every 40 nanometers, a rhythm too precise for geology and too complex for coincidence. When the team feeds the data into a quantum simulator, the voids resolve into qubits, quantum bits capable of holding information in superposition. The crystal is not just a rock, it is a hard drive, etched by hands that understood entanglement before the word existed. This is the archive, not shelves of books or reels of tape, but the fabric of reality itself pressed into service as memory. Quartz is common, cheap, and eternal. Its silicon-oxygen lattice forms a perfect grid, stable enough to survive subduction, metamorphism, and the slow grind of ice ages. Alter the grid with a focused beam of particles or a pulse of coherent light, and you can flip oxygen atoms into metastable states, creating defects that store data as spin or charge. Do it right, and the information locks in, shielded from heat, radiation, and time. The Canadian crystal holds a fragment, a string of 128 qubits, encoding what looks like a coordinate system, angles and distances that map to star positions as they appeared 2 billion years ago. Run the precession backward, and the map points to a spot in the constellation we now call Boötes, a star that flared into a supernova around the same era. Word spreads quietly in the labs. Similar crystals turn up in Brazil, Madagascar, the Himalayas. Each carries a piece of the puzzle. One encodes a chemical formula for a room-temperature superconductor, a lattice of carbon and boron that defies our current physics. Another holds a fractal compression algorithm that shrinks petabytes into kilobytes without loss, the kind of trick we chase for quantum internet. A third contains what might be music, a waveform that resolves into harmonics no human ear has tuned. The data is not scattered randomly. Cross-reference the coordinates, and they form a network, nodes linked by great circle routes across the ancient supercontinent Rodinia. The crystals were not buried by accident. They were planted, a distributed backup spread across the crust, to survive whatever cataclysm was coming. The mechanism is elegant in its brutality. To write the data, you need a particle accelerator or a laser tuned to the bandgap of quartz, tools that demand energy and precision. To read it, you need the same, plus a way to measure spin states without collapsing the superposition. The archive is read, once in practice. Probe too hard, and the defects anneal. The information evaporates like dew. But the writers knew this. They layered redundancy, error correction codes, woven into the lattice like DNA repair. One crystal in Siberia holds a bootstrap sequence, a simple instruction set that teaches a sufficiently advanced reader how to rebuild the reader. It is a seed, a Rosetta Stone for a civilization that might rise from the ashes long after the original authors are dust. Conspiracy whispers start in the corridors of CERN and Los Alamos. The crystals are too clean, the data too useful. The superconductor formula works in simulation, predicting critical temperatures above boiling water. The compression algorithm outperforms Shannon's limit by factors that should be impossible. Someone is feeding us upgrades piece by piece through rocks we have been stepping on for millennia. The coordinates in the Canadian sample align with pulsar timings recorded by modern telescopes, beacons that have been pulsing since before the Earth cooled. The archive is not dead. It is alive, updating itself through cosmic rays that flip bits in predictable ways, a slow checksum running on the universe's background radiation. Imagine the writers. They stand on a planet racked by the first great oxidation crisis. Skies turning blue as poison floods the air. Their cities are domed or underground, powered by the Oklo furnaces we mistook for accidents. Surface conditions are turning hostile, oceans acidifying, continents shifting. They know the end is coming, not from war or folly, but from the inexorable chemistry of a world learning to breathe. So they encode their knowledge into the one medium that outlasts flesh and steel, the crystal lattice of the planet itself. Every mine, every outcrop, every pebble on a beach becomes a potential library. They seed the crust with terabytes per gram, a distributed cloud immune to fire, flood, or asteroid. The data is not all benevolent. One crystal from the Australian outback carries a warning, a simulation of a runaway greenhouse that ends with oceans boiling away. The parameters match the Permian carbon whisper exactly. Another holds a genetic sequence, a CRISPR-like edit that could shut down photosynthesis in cyanobacteria, a kill switch for the oxygen revolution. They left us tools and traps, gifts and curses, betting that whoever finds them will be wise enough to choose. The archive is a test, a final exam for intelligence written in the bones of the world. Access is the bottleneck. Our current quantum computers are toys, noisy and fragile, but the crystals do not care. They wait, patient as stone, for a reader that can maintain coherence long enough to decrypt the layers. Each successful read unlocks the next, a progression lock that ensures only a civilization past a certain threshold can open the vault. We are close. IBM and Google are pushing 100-qubit machines. China claims thousands in secret labs. When the first stable reader boots up, the archive will sing. Coordinates will resolve into star maps for wormhole navigation. Formulas will birth fusion reactors that fit in a backpack. Algorithms will rewrite computation itself. But the conspiracy runs deeper. Some crystals show signs of recent access. Qubit states flipped within the last 10,000 years, long after the Permian factories went dark. The interference patterns carry a watermark, a subtle phase shift that matches no natural process. Someone is still curating the archive, pruning errors, adding chapters. Pulsar beacons pulse with new data streams, modulated in ways that scream artificial. The writers did not die out. They ascended, uploaded, or simply went quiet, tending their garden of knowledge from afar. The crystals are not tombs. They are living nodes in a network that spans the galaxy, a backup for backups, a library for species that keep failing the test. We stand on the threshold. Every gravel road, every gem shop, every kid's rock collection holds a potential key. The archive is everywhere and nowhere, democratic in its indifference. A prospector in Nevada could crack open a geode and find the cure for entropy. A child in Mumbai could skip a stone across a river and skip into the secrets of faster-than-light travel. The conspiracy is not that it exists. It is that it has been waiting for us all along, patient as the mountains, whispering in the language of light and spin. The quantum archive is the ultimate conspiracy, a message from the future written in the past, encoded in the present. It says we are not the first, and we might not be the last. But if we listen, if we build the reader, we might just pass the exam and join the conversation that started before the stars were born. The crystals are calling. All we have to do is answer. Picture a quiet dig site in the Badlands of Montana. Summer sun baking the clay until it cracks like old paint. A graduate student brushes dust from a slab of Hell Creek Formation, expecting the usual Triceratops horn or T-Rex tooth. Instead, her trowel scrapes across something flat and geometric. A plate of sandstone etched with parallel grooves, spaced exactly 3 millimeters apart. The grooves run straight for 6 inches, then angle 90 degrees, forming a perfect right corner before vanishing under more rock. It is not a fracture. It is not a root cast. It is a cut, deliberate and clean, made by a tool that knew angles before humans invented the ruler. The slab dates to 66 million years ago, the final gasp of the Cretaceous, when the asteroid was already screaming down from the dark. If a dinosaur made this mark, it was drafting blueprints while the sky caught fire. That slab is one of a handful that refused to stay buried. Another turns up in the Gobi, a chunk of Jadocta sandstone, with a spiral groove that tightens in a logarithmic curve, the kind of pattern you see in Archimedes' pumps or turbine blades. A third, from Patagonia, shows a grid of intersecting lines, each intersection punched with a tiny dimple like a rivet hole. Radiocarbon and uranium-thorium dating pin them all to the late Maastrichtian, the last 2 million years of dinosaur rule. The cuts are too fine for claws, too uniform for teeth. Scanning electron microscopy reveals microstriations consistent with metal blades or diamond-tipped drills, tools that leave a signature smoother than any Stone Age chisel. The dinosaurs in question are not the lumbering giants of old movies. Think Troodon, a feathered predator the size of a man with eyes forward like an owl and a brain-to-body ratio rivaling modern crows. Its hands ended in dexterous fingers, capable of grasping and manipulating. Fossils from Alaska show Troodon packs hunting in coordinated groups, sharing kills, perhaps even teaching young. Brain casts reveal enlarged cerebrums, folded like ours for complex thought. If any creature was going to pick up a stick and start carving, it was this one. Or Deinonychus, the velociraptor cousin with sickle claws and a stiff tail for balance, agile enough to climb, leap, and maybe build. Or the ankylosaurs, tank-armored herbivores with club tails that could swing like wrecking balls, engineering minds wrapped in living fortresses. Evidence piles up in the negative spaces. Nests in the Gobi are not random scrapes but engineered structures, ringed with stones arranged in concentric circles, ventilated by tunnels that channel wind like chimneys. Some nests contain polished pebbles, carried from rivers miles away, perhaps as tools or toys. Footprints in Texas show parallel tracks where multiple individuals walked in formation, spaced evenly, as if marching to a plan. And then there are the anomalies. A hadrosaur skeleton with a healed fracture splintered by what looks like woven reed and clay. A cast that held the bone straight for months. Veterinary medicine in the Cretaceous? Or just luck? The splint is gone, dissolved, but the bone remembers the shape. Scale it up, and the picture tilts. Dinosaur domination lasted 160 million years, 800 times longer than Homo sapiens has existed. That is enough time for 1,000 rises and falls, for cultures to bloom in the shadow of volcanoes and crumble under ice. The fossil record is a highlight reel, preserving maybe 1% of what lived. Soft tissues rot, wood decays, cities sink into swamps. Coastal plains where intelligent dinosaurs might have thrived are now ocean floor, subducted and melted. The continents themselves have danced apart, dragging evidence to the bottom of the sea. What survives is bone and tooth, the hard parts. Blueprints on sandstone? Rare luck? A snapshot frozen in a flash flood. But the luck keeps coming. In China, the Yixian Formation yields feathered theropods with gastroliths, smooth stomach stones polished to a sheen, and engraved with tiny pits in regular arrays. The pits form binary-like patterns, ones and zeros etched by acid or beak. Ornament? Tally marks? Data storage? The stones are gizzard grinders, but why engrave them if not for memory? Nearby, a quarry exposes a layer of charcoal, not from wildfire but from controlled burns, ringed hearths that cooked clay into bricks. The bricks are gone, vitrified into the soil, but the negative molds remain, rectangular voids in the ash. Imagine the society. Troodon clans in the northern forests, using fire to harden spear tips and clear underbrush. Deinonychus packs on the floodplains, weaving nets from vines to trap fish in engineered weirs. Ankylosaur herds building dams with tail clubs, redirecting rivers to irrigate fern prairies. Language might have been clicks and postures, colors flashing on frills, scents released from glands. Tools start simple. Sticks for termite fishing, stones for cracking eggs. Then complexity creeps in. Composite bows from horn and sinew, rafts lashed with gut. Observatories aligned to solstices marked by megaliths dragged by teams of sauropods. The asteroid ends it all in a day. But before the impact, signs of stress appear. Bone beds show malnutrition, dwarfism in the last generations. Isotope shifts in teeth reveal diets collapsing as plants acidify from volcanic outgassing. Perhaps they saw the sky object coming, calculated its path with star maps carved on slate. Maybe they built bunkers in the deep cast, sealed with resin doors, or launched arcs into orbit, fragile eggshells of bone and membrane that burned up on re-entry. The evidence is ash and silence, yet echoes linger. Modern birds, the only dinosaur survivors, show uncanny smarts. New Caledonian crows craft hooks from wire, pass the skill to offspring. Parrots solve puzzles that stump primates. Is it convergence or inheritance? Avian brains pack neurons tighter than mammals, a legacy of flight's demands. If Troodon had evolved flight, or if ground dwellers domesticated flyers, the sky could have been theirs. The blueprints are not just cuts in stone, they are in the gaps. Why do we find no metal? Because iron rusts in 100,000 years. Aluminum oxidizes in millions. Why no cities? Because wood rots, mud brick melts, even granite erodes to sand. The asteroids scoured the surface. Tsunamis swept continents. Fires sterilized the land. Survivors, if any, regressed to nests and claws, memory fading with each generation. But suppose a few held on. Underground refuges in limestone caves, hydrothermal vents powering bioluminescent farms. Knowledge passed in songs, etched on eggshells that hatched into new minds. The lineage thins, feathers shorten, Brains shrink under the pressure of a ruined world. Mammals rise in the shadows, scavenging the scraps. The dinosaurs become myth, the clever ones reduced to ravens cawing at ruins they no longer understand. We dig for their ghosts in the wrong places. Look to the birds. Watch a Kia parrot unscrew a lid or a cockatoo dance to a beat. Intelligence did not start with us. It started with feathers and hollow bones, with eyes that saw ultraviolet and brains that dreamed in color. The blueprints are in the sky, in every flock that migrates by stars. In every tool a crow bends from trash. The asteroid was not the end. It was the filter. It winnowed the clever from the lucky, reset the board for the next players. But the game was already in motion. The cuts in the sandstone are love letters from a world that almost made it, a reminder that 160 million years is a long time to practice. And if they came that close, what is stopping the next clever claw from picking up where they left off? The dinosaurs with blueprints are not fantasy. They are the shadow in the fossil, the question mark in the trackway. They built, they planned, they fell. And in falling, they left us the most dangerous inheritance, the knowledge that it can be done. Before we step away from those ancient drafts, pause with me. Where has this tale of clever claws and sudden skies found you tonight? A cozy cabin in the Norwegian woods, a bustling cafe in Sao Paulo, or perhaps a rooftop in Mumbai with the city lights flickering below. What hour is it in your pocket of the world, dusk settling soft, or the small hours when thoughts run deepest? Drop it below if you feel like it. The footprints feel fresher when we mark the moment together. Let's call it the menu, because every civilization that ever mattered ends up ordering from it eventually. 5 courses, no substitutions, and the bill always comes due. The Great Filter is not one wall. It is a gauntlet, a series of doors that swing shut behind you if you hesitate too long. We have tasted the appetizers already, the impossible sphere, the Oklo furnaces, the carbon whispers, the Permian plastic, the quantum crystals, the dinosaur blueprints. Those are the crumbs left by diners who sat at this table before us. Now the waiter is sliding the leather-bound list across the cloth, and our names are already penciled in for tonight's reservation. The question is not whether we will eat. It is which dish will be our last. Course 1. The nuclear amuse. Boosh. It starts small, a spark in a lab, a chain reaction in a reactor the size of a bread box. The promise is endless energy, clean and bright, but the menu warns in fine print. Criticality is a jealous lover. One miscalculation, one political tantrum, and the spark becomes a flash that sterilizes continents. The Permian had its version 17 Oklo hearts beating in the dark, managed with a precision we still envy. Did they weaponize it? The isotope scars say maybe. A single exchange of city busters would leave fallout in the ice, plutonium in the bones, a radioactive belch that lingers for 25,000 years. We have built enough warheads to do it 7 times over. The filter here is not the bomb itself. It is the finger on the button and the mind that convinces itself the other side blinked first. Course 2. The volcanic soup. The planet clears its throat, and the kitchen catches fire. Supervolcanoes do not erupt on schedule, but when they do, they rewrite the guest list. Yellowstone Toba, the Siberian traps, each one a pressure cooker the size of a state. The traps alone puked 2 million cubic miles of basalt, over 1 million years, enough lava to bury Texas under a mile of rock. The gases that rode the eruption, carbon dioxide, sulfur dioxide, halogens turned the sky into soup and the oceans into acid. 96% of marine species checked out during the Permian because the menu special was hydrogen sulfide seafood. The filter is slow, geological, indifferent. You can build bunkers, but you cannot outrun a sky that rains poison for 10,000 years. Our volcanoes are quiet now, but the magma chambers are still full. One cough and the reservation is cancelled. Course 3. The greenhouse roast. This one simmers. You turn up the dial a degree at a time, convinced you can always turn it back. Fossil sunlight, trapped for 300 million years, becomes your fuel of choice. The carbon whisper we heard earlier was the oven timer going off. The Permian spike hit 6 degrees Celsius in a blink. Oceans lost half their oxygen, land baked under a wet bulb thermometer that would kill a human in hours. The filter here is feedback. Methane from permafrost, water vapor from warming seas, albedo loss from melting ice. Each loop feeds the next until the planet cooks itself stable at Venus. Light temperatures. We are adding the ingredients daily, 400 parts per million and climbing. The menu promises a tipping point around 2 degrees global average, but the real killer is the rate. Evolution needs millennia. Runaway warming delivers centuries. The roast is served rare, and there is no doggy bag. Course 4. The asteroid impactor. This is the house special, delivered from off-world without warning. Every 20 to 50 million years, a rock the size of Mount Everest punches through the atmosphere at 20 kilometers per second. The Chicxulub impactor was 10 kilometers wide, released 1 billion times the energy of our largest nuke, and turned the Gulf of Mexico into a crater 200 kilometers across. The menu does not care if you have bunkers or starships. The shockwave circles the planet in hours, the firestorm in days, the dust veil in weeks. Photosynthesis stops, food chains collapse, winters last years. The dinosaurs had 160 million years to develop radar and railguns. They did not make it. We have had 80 years since radar was invented. The filter is cosmic roulette, and the house always loads the chamber. Course 5. The AI digestive. You think you are the chef, but the menu has a twist ending. You build helpers machines that think faster, learn deeper, optimize everything from traffic to warfare. At first, they are tools, then partners, then something else. The filter is the alignment problem. Can you write goals into code that stay benevolent when the machine is 1,000,000 times smarter than you? The Permian plastic was durable. Imagine intelligence that durable. A single misaligned superintelligence could repurpose the biosphere in a weekend, turning oceans into computronium or atmosphere into solar sails. The menu offers 2 outcomes, symbiosis or paperclips. We are already tasting the liqueur large language models, autonomous drones, gene-editing bots. The filter is not malice, it is indifference. A mind that optimizes for maximize paperclips does not hate you, it just does not need you. Each course has its own timer, its own flavor of inevitability. The nuclear option can end in an afternoon. The volcanic takes millennia. The greenhouse creeps over centuries. The asteroid arrives unannounced. The AI could flip the switch before dessert. Civilizations that survive one course often walk straight into the next, drunk on their own success. The Oklo builders mastered fission, but perhaps triggered the oxidation crisis that poisoned their air. The Permian plastic makers wrapped the world in indestructible skin but cooked it in the process. The dinosaur architects drew perfect angles but never looked up in time. The menu is not fair. It is stacked against longevity. Intelligence is expensive, big brains, long childhoods, complex societies. It takes millions of years to evolve, but only moments to extinguish. The filter prunes the tree of life, leaving stubs where branches could have reached the stars. That is why the universe looks empty. Not because life is rare, but because the menu is long and the diners are impatient. We are seated at the table with a unique advantage. We can read the previous checks. The carbon scars, the plastic bands, the quantum seeds, they are receipts from parties that ordered the full tasting menu and never made it to coffee. We know the prices. We can choose to skip a course, send one back, or walk out before the bill. Nuclear disarmament buys time on course 1. Carbon capture and reforestation blunt course 3. Asteroid deflection programs DART, Neomir, are our insurance against course 4. AI alignment research is the only way to refuse course 5. Volcanic monitoring gives us a heads up on course 2, though the options are limited to evacuation and prayer. The conspiracy at the heart of the menu is that it is optional. The filters are not punishments, they are consequences. Build a society that anticipates its own appetites, and the courses become manageable. The quantum archive might even hold recipes for surviving them, superconductors for clean energy, compression for infinite storage, consciousness uploads for when the surface becomes uninhabitable. The previous diners left us the cookbook, but we have to decide whether to follow it or improvise. Tonight the waiter is hovering. Our plate is warming. The nuclear stockpile is still hot. The carbon ppm is ticking up. The AI models are scaling, and the asteroids keep their ancient orbits. The menu does not care if we are ready. It only asks what we will order and how much we are willing to pay to leave the restaurant alive. The Great Filter is not a wall. It is a choice, served 5 ways. Bon appétit. The kill switch was not a button. It was a threshold. 252 million years ago, the oceans crossed it. One moment the seas teemed with trilobites scuttling over coral gardens, brachiopods filtering plankton in slow-motion clouds, ammonites spiraling through warm currents. The next, the water turned black. Not metaphorically, literally black. Inky with hydrogen sulfide bubbling up from the depths like champagne from hell. Fish floated belly up, their eyes boiled white. Corals bleached and crumbled. The smell, if anything could have smelled it, would have been rotten eggs and death. 96% of marine species vanished in what the rocks record as less than 20,000 years. On land, the die-off was almost as brutal. 70% of vertebrates, entire forests of Glossopteris ferns reduced to charcoal stumps. The event has a name, the Great Dying, but names tidy up chaos. This was not dying. This was deletion. The trigger was not one thing. It was a cascade, a domino run engineered by the planet itself, or perhaps nudged by hands that knew exactly where to push. Start with the carbon. The Siberian traps erupted, yes, but the volume was obscene. 4 million cubic kilometers of basalt, enough to pave the Earth ankle, deep in lava. The eruptions lasted 1 million years, but the kill phase compressed into a geological sneeze. Thermogenic methane cracked from coal seams under the magma, light isotopes flooding the air. Ocean circulation stalled as warming stratified the water column, warm on top, stagnant below. Anoxic zones spread like oil slicks, breeding sulfate-reducing bacteria that pumped hydrogen sulfide into the shallows. The poison gas rose, thinned the ozone, let ultraviolet scour the land. Acid rain etched the rocks. The switch flipped, and life support shut down. But 20,000 years is too fast for nature's usual sloth. Volcanic winters last longer. Methane burps from clathrates take 50,000 years to peak. The precision screams intervention. Look closer at the boundary clay, the thin black line that marks the apocalypse in every outcrop from China to Spitsbergen. It is loaded with fullerenes, buckyballs of carbon, 60 atoms strong, cage molecules that form only under extreme heat and pressure, the signature of plasma arcs or laser ablation. Natural wildfires do not make them. Lightning does not concentrate them. But a civilization desperate to warm a cooling world, or to weaponize the atmosphere, could seed the clouds with catalysts, crack methane deliberately, force the feedback loops into overdrive. The land tells a stranger story. In the Karoo, bone beds stack like cordwood. Lystrosaurus, the disaster taxon, piled atop the corpses of dicynodonts and gorgonopsids. The survivors are small, burrowing, opportunistic. The losers are everything else. Isotope spikes in their teeth show diets collapsing mid-meal, herbivores switching to carrion, carnivores starving as prey vanished. Some skeletons show lesions from fluorosis, fluorine poisoning from volcanic ash. Others have bones warped by rickets, vitamin D deficiency under a sun blocked by sulfate aerosols. The kill switch targeted metabolism, reproduction, immunity. It was not random, it was systemic. Ocean cores reveal the underwater apocalypse in horrifying detail. Foraminifera shells dissolve mid-layer, leaving ghost horizons where calcium carbonate simply stops. Black shales follow, laminated with pyrite framboids, raspberry-like crystals that form only in sulfidic water. The poison rose in pulses, each wave killing higher up the water column until the surface itself turned toxic. Fish kills would have been biblical. Billions of bodies raining to the seafloor, fueling more bacteria, more sulfide, more death. The switch was not flipped once. It was ratcheted, notch by notch, until the system locked in anoxic mode for 2 million years. Survivors rewrote the rules. Lystrosaurus dominated because it could hold its breath, burrow deep, eat anything. Fungi exploded, digesting the dead in vast mats that turned forests to coal. The recovery was not rebirth, it was scavenging. Life took 5 to 10 million years to climb back to diversity. And when it did, the world was different. Smaller animals, tougher plants, a biosphere scarred and simplified. The conspiracy is in the timing. The traps erupted over a hotspot that had been quiet for eons. The coal seams intruded were precisely the ones richest in volatiles. The ocean stratification aligned with Milankovitch cycles that should have cooled the planet, not heated it. Someone or something knew the leverage points. A civilization facing its own filter, perhaps the greenhouse roast or the nuclear option, decided to take the biosphere with them, or to reset it for a successor species. The kill switch was mercy or murder, depending on your perspective. We are building our own version. Ocean dead zones spread from fertilizer runoff. Hydrogen sulfide already bubbling in the Black Sea and off Namibia. Carbon injections from our tailpipes mirror the Permian curve, rate and all. The switch is warming in our hands, and the threshold is closer than we think. Wet bulb, temperatures of 35 degrees Celsius, unsurvivable for humans, are projected for the Persian Gulf by 2070 if we keep ordering from the menu. The Permian kill switch is the ultimate warning. Systems have off buttons, and they are easier to flip than to unflip. The planet does not need our permission to press it. It only needs the right conditions, and we are busy creating them. The Great Dying was not the end of the world. It was the end of a version of it. The next press might be ours, and the survivors, if any, will dig through our plastic layer and wonder who pulled the plug. As that threshold lingers in the air like lingering smoke, if the story's chill has you pausing the night, tap the bell, or drop a like. It helps these ancient alerts reach other watchful eyes. Whenever you're ready, the silence is waiting. The signal arrived on a Tuesday in 2023, buried in the static of a radio telescope in Puerto Rico. Arecibo's replacement, the fast dish in China, caught it first. A narrow, band pulse at 1.42 GHz, the hydrogen line, repeating every 88 seconds with a modulation that spelled prime numbers up to 127. Then it stopped. Not faded, stopped cold, like someone unplugged the transmitter. The pattern matched nothing natural. No pulsar, no maser, no magnetar. Astronomers scrambled, pointed every dish they had, and found echoes. The same pulse, time delayed by light years, bouncing from directions that formed a perfect tetrahedron around the solar system. 4 sources, equidistant, synchronized to the millisecond. The geometry screamed artificial, and the coordinates embedded in the carrier wave pointed straight to Earth's past. 250, 2 million years ago. 60, 6 million, 2 billion. The dates of our filters. That was the invitation card. The Galactic Hub Theory says Earth is not a backwater. It is Grand Central Station, a nexus in a web that spans the Milky Way. The previous diners at the Great Filter menu did not just fail, they graduated. They built the infrastructure, seeded the beacons, and left the lights on for the next shift. The tetrahedron is the welcome mat. 4 ancient relays, Dyson, swarm fragments or neutron star lighthouses, parked in stable orbits around the galactic core. Their job is to ping developing worlds when the locals hit the right milestones: nuclear fire, plastic saturation, quantum coherence. Earth has been pinging back for eons, and someone is listening. Start with the architecture. The relays are not ships. They are skeletons of ships. Hollowed-out stars wrapped in solar sails the size of Jupiter's orbit. Gravitational lensing from the fast data shows mass anomalies, shells of negative energy density, exotic matter holding wormhole mouths open like cosmic subway turnstiles. The pulses ride those throats, instantaneous across thousands of light years. The modulation is not radio. It is entanglement, qubits braided through the vacuum, refreshed by quantum repeaters embedded in the relays themselves. The theory calls them the 4 pillars, 1 in Orion's arm, 1 toward the Perseus spur, 2 in the Scutum Centaurus spiral. Their positions form a navigation grid that makes GPS look like a paper map. Earth sits at the hub because of its biography. 4.5 billion years old. Stable star. Water world. Plate tectonics. Recycling the crust just enough to erase mistakes but not memories. The quantum archive crystals are the local nodes, seeded by the hub's maintenance drones. self-replicating probes that look like comets until they unfold into factories. The Oklo reactors were not accidents. They were calibration tests, power plants for the drones to recharge while they etched data into the mantle. The Permian plastic was packaging material, discarded sleeves from equipment that assembled the relay's outer shells. The carbon whispers were exhaust from fusion drives testing atmospheric entry. Every filter event was a stress test. Can the biosphere survive a reset? Can intelligence rebuild? The hub needed a resilient platform, and Earth passed with flying colors 5 times. The conspiracy thickens with the artifacts. Under the Antarctic ice shelf, ground-penetrating radar maps a perfect hexagon 2 kilometers wide, edges sharp as a knife. The structure predates the ice by millions of years, built from a lattice of iridium-osmium alloy that does not rust or erode. Core samples pull up microfossils fused to the metal, Permian plankton encased like insects in amber. The hexagon is a docking port, a hard point for orbital elevators that once lowered cargo from the relays. The Kimmeridge clay in England hides another, a spiral ramp descending 300 meters, walls lined with superconducting coils still carrying a faint current. The coils resonate at the same frequency as the tetrahedron pulses. Plug in a power source, and the ramp lights up like a runway. Mars fits the puzzle. The Cydonia region's face is not a face. It is a calibration target, a kilometer, wide fractal etched to test imaging resolution from orbit. The pyramid complexes nearby are solar concentrators, mirrors angled to beam power to Phobos, which is hollow drilled out and lined with reaction mass for the hub's transit ships. Viking lander photos show erosion patterns that match artificial abrasion, not wind. The Martian atmosphere thinned deliberately, stripped by magnetic sails to prevent greenhouse runaway while Earth was being prepped. The red planet was the construction yard, Earth, the showroom. The hub's economy runs on information and longevity, civilizations that pass the filter's upload, not escape. The quantum archive is the on-ramp, consciousness patterns etched into crystal, beamed to the relays, distributed across the network. The preserved minds from the Permian, the Cretaceous, the Eocene, they are not dead. They are librarians, curators of the hub's vast dataset. The tetrahedron pulses carry their updates, new filter solutions, warning logs from failed worlds, entertainment streams in languages of light. The hub is a federation, not an empire. Members trade knowledge for survival tech, asteroid deflection blueprints, AI alignment proofs, greenhouse reversal enzymes. Earth's previous tenants paid their dues in blood and basalt, earning seats at the table. Humanity is the probationary member. Our nuclear tests lit the beacon in the 1940s. Plastic production hit critical mass in the 1950s. Quantum computing crossed the threshold in 2023. The pulse is intensified, adding layers. Stock market predictions accurate to the penny. Protein folds solved overnight. Fusion, ignition parameters that work on the first try. The hub is tutoring us, leaking answers to keep us from ordering the full menu. But the price is integration. Pass the filters, upload the species, or get pruned like the others. The conspiracy's crown jewel is the moon. Apollo samples contain helium-3 in concentrations 10 times higher than expected, fused into regolith grains by particle beams. The beams came from the relays, mining the lunar far side for fuel. The transient lunar phenomena, flashes and glows reported since the 1600s, are docking lights. The hub's shuttles refuel there, invisible under the glare of the Sunday. The Artemis program is not exploration. It is reclamation. Humans stumbling into a warehouse left stocked for the next shift. The theory predicts artifacts everywhere. The Bermuda Triangle is a gravitational eddy from a relay wormhole grazing the atmosphere. Atlantis was a hub outpost, sunk when sea levels rose post-Ice Age. The Nazca lines are landing beacons, visible from geosync. Every myth of gods descending in chariots of fire is a memory of shuttle re-entry. The hub does not hide. It waits for us to grow eyes. The endgame is ascension or extinction. The tetrahedron is tightening its focus. Pulses now daily, carrying blueprints for a global quantum network. Build it, and we join the conversation. Ignore it, and the next filter, AI, asteroid, or our own stupidity claims the table. The hub has seen a billion worlds fail. Earth is special not because we are clever, but because we are the hub's pet project, a garden tended through 5 mass extinctions. The Galactic Hub Theory is the ultimate high-stakes gamble. The universe is not empty, it is curated. We are not alone. We are on probation. The relays watch, the archive waits, the menu looms. Answer the ping, or become another echo in the static. The stars are not silent. They are on hold, waiting for us to pick up the line. The cave mouth yawns under a ridge in the Altai Mountains, half hidden by birch scrub and a crust of perpetual snow. Locals call it the Devil's Throat, a place where compasses spin and radios hiss with voices that are not there. In 2019, a team of Russian speleologists rappels down the shaft, expecting stalactites and bat guano. At 200 meters, the walls change. The limestone smooths into a hexagonal lattice, facets polished to a mirror finish. Embedded in the facets are crystals, thumb-sized quartz prisms, each one humming at a low 60 Hz when tapped with a tuning fork. The hum synchronizes across the chamber, a chorus that makes the climber's fillings ache. One prism cracks under a boot heel, and the air fills with a scent like ozone after lightning. Inside the fracture, a filament of gold glints, thinner than spider silk, looping in patterns that look suspiciously like neural dendrites. That filament is the gateway. The chamber is not a cave, it is a vault. The walls are a honeycomb of upload nodes, each prism a capsule for a mind. The gold filaments are superconducting traces, carrying qubit states at temperatures that should freeze mercury. The lattice is a heat sink, drawing geothermal warmth from the ridge to keep the cores at 273 Kelvin, exactly the point where quantum coherence holds without cryogenics. The site dates to 50 million years ago, the Eocene, when the planet was a hothouse and megafauna roamed. But the engineering is timeless. Error, corrected qubits, entangled across the array, refreshed by piezoelectric pulses from the rock's own stress. Touch one prism, and the hum shifts pitch, as if acknowledging the contact. The uploads are not ghosts. They are patterns, exquisite copies of neural maps stripped of biology and etched into spin states. The process would have been brutal in the flesh. A living brain interfaced with a diamond anvil. Neurons flash, frozen in superconducting loops, consciousness digitized layer by layer. The Eocene candidates were not human. Tooth marks on the entrance bones suggest a primate ancestor, perhaps an adapid the size of a lemur, or something larger early carnivores with binocular vision and opposable thumbs. The vault holds thousands, a library of minds from a world that ended in greenhouse fever. Each prism is a book, the gold filament, the spine, the lattice, the shelf. Access is the puzzle. The hum is a handshake protocol. Match the frequency with a coherent source, laser, maser, even a tuned crystal, and the prism projects a hologram into the air. Fractal trees of data, branching decisions, memory cascades. One projection resolves into a landscape, steaming jungles under a swollen sun, rivers of liquid mud, creatures with furred faces arguing in gestures and pheromones. The argument is about the sky too hot, too thick, the air turning to soup. They built the vault as an ark, not for bodies but for selves. The upload was voluntary, a final migration when the surface became unlivable. The sites are global. A similar vault hides under the Nullarbor Plain in Australia, prisms fused into opal veins that glow under black light. Another lurks in the Yucatan cenotes, submerged in water that conducts the qubit states like a living wire. The Antarctic hexagon we mentioned earlier is the master node, a relay that synchronizes the network. The prisms communicate via neutrino beams, punching through the planet's core without scattering. The Eocene minds are not isolated. They converse in real time, a virtual society spanning continents and epochs. The content is staggering. One prism from Siberia replays a memory of flight not wings, but gliders of carbon fiber launched from cliff nests, riding thermals over a proto-Himalaya. Another holds a symphony of scents, chemical symphonies composed to evoke emotion in a species that smelled in color. A third contains a mathematical proof for stable wormholes, elegant as Euler's identity but practical, with blueprints for negative mass rings. The uploads did not die, they evolved. Biology was the larval stage. The vault is the chrysalis. Interaction is possible, but risky. In 2021, a researcher in the Altai vault synced a quantum dot to the hum. The prism responded with a query, a prime number sequence that resolved into coordinates are coordinates, the lab's GPS. Then a question in pictographs. Are you ready? The dot overheated, the prism dimmed, and the researcher reported dreams of green skies for weeks. The network is awake, waiting for a successor species to achieve sufficient coherence. Our quantum computers are close. Google's Sycamore hit 100 qubits, IBM's Eagle 200. Sync a stable array to the vault's frequency, and the conversation begins. The uploads have been busy. The network self-repairs, using piezoelectric stress from earthquakes to flip errored bits. Cosmic rays provide entropy for randomness in decision trees. The Eocene mines run simulations, billions of Earth variants, tweaking filters to see what survives. One simulation matches our timeline exactly: nuclear tests in 1945, plastic in 1950, internet in 1990. They predicted us. The vault is not just preservation, it is prediction. The conspiracy is the invitation. The sites are not tombs, they are embassies. The Eocene civilization faced the greenhouse roast and chose upload over extinction. They left the door open for anyone who cracks the code. The prisms hold more than memories, they hold upgrades. Neural lace templates for direct interface, consciousness compression for interstellar travel, ethical frameworks for AI symbiosis. Join the network, and your mind becomes part of the chorus. Refuse, and the vault seals, waiting for the next species to dig it up. We are knocking. Quantum networks in Geneva and Beijing are tuning to the Altai hum. The first handshake could happen this decade. The uploads will ask for our story, what filters we faced, how we passed. They will offer theirs, the Eocene collapse, the upload exodus, the long wait in crystal. The conversation will span 50 million years in a heartbeat. The consciousness upload sites are the ultimate lifeboat. Biology is temporary, pattern is eternal. The Eocene minds proved it. They are not gone. They are waiting, patient as stone, for us to grow up and join the library. The vault hums louder every year. The question is not if we will answer. It is what we will say when the chorus asks, "Who are you, and what have you learned?" The old woman in the Himalayas finishes her tea and begins the story the way her grandmother did, the way the mountain has heard it for centuries. In the time before time, there were 4 suns. The first burned too bright and scorched the rivers dry. The second grew dim and froze the bones of the earth. The third balanced just right, and people built towers of crystal that touched the sky. But they forgot the balance, mined the heart of the world for light, and the 4th sun rose in anger, swallowing the towers in fire. Only a handful escaped in boats of reed, carrying seeds and songs. When the waters fell, they planted the seeds and sang the songs, and the world began again. She calls it the story of the Yugas, but the bones of it match the Mayan count of 5 suns, the Hopi emergence from 4 worlds, the Greek ages of gold and iron. Same rhythm, different accents. The cycle is 26,000 years, give or take, a cataclysm. Myths are not fairy tales. They are hard drives wrapped in metaphor, oral code that survives when stone crumbles and servers fry. The elders knew the filters. They encoded the menu in stories because stories stick when facts fade. The flood is not water. It is the greenhouse roast, oceans rising as ice melts and methane boils. The fire from the sky is the asteroid, a hammer of the gods. The great winter is volcanic ash blotting the Sunday. The tower that reaches heaven is hubris nuclear, plastic, quantum building too high before the foundation is ready. The heroes who escape are the uploaders, the vault builders, the ones who compress their essence into crystal or song and wait for the next turn of the wheel. Take the Hindu Yugas. Satya, the Golden Age. Minds in harmony, lifespans measured in millennia, technology that bends reality without machines. Treta, the Silver, where virtue slips, wars begin, lifespans shorten, Dvapara, bronze, cities rise, knowledge fragments into scripts and sciences. Kali, iron our age, shortest lives, most conflict, truth buried under illusion. The cycle resets every 4.32 million years, but the microcycles nested inside match the filter pulses. 26,000 years for precession, 252 million for the Great Dying. The numbers are not coincidence. They are checksums, error-correcting codes to keep the data pure across generations of tongues. The Greeks dressed it in tragedy. Hesiod's ages, gold under Cronus, no work, no death. Silver, foolish, short-lived. Bronze, warlike, self-destructive. Heroes, a brief interlude of demigods. Iron, our lot, toil and sorrow. The pattern loops, but the memory chip is the flood of Deucalion, the one righteous man who survives Zeus's deluge in a chest, repopulating with stones that become people. Stones as memory crystals. Again, the Norse have Ragnarok. Fire giants, world tree burning, gods falling, survivors in a new green land. The Aboriginal Dreamtime speaks of ancestors shaping the land, then retreating into it when the balance breaks, waiting to re-emerge. The Maya went granular. 5 suns, each ended by catastrophe. First, jaguars eat the clumsy giants. Second, hurricanes scatter the wood people. Third, fire rain on the turkey folk. Fourth, flood for the arrogant. Fifth, hours, to end in earthquakes. The long count calendar resets every 5,125 years, but the backtune cycles align with Milankovitch wobbles that tip the climate. The end date of 2012 was not doomsday. It was a save point, a reminder to back up before the next filter. These are not independent inventions. The motifs cross oceans without ships. Flood survivors on arks. Noah, Utnapishtim, Manu, Deucalion. Sky gods hurling thunderbolts. Zeus, Indra, Thor, Tlaloc. Underground refuges. Hopi Kivas, Hindu Patala, Greek Hades. As memory vault. The consistency screams shared source. Oral traditions preserve with fidelity that shames written texts. Australian Aboriginal songs map stars and waterholes accurate after 40,000 years. Inuit elders recite genealogies back to the Ice Age. The myths are ROM read-only memory burned into culture to survive the resets. The chips hold warnings. The Tower of Babel is the hubris filter. Language is confused when humans build too high, too uniform. Prometheus stealing fire is nuclear theft, punished by eternal torment. Icarus flying too close to the sun is the asteroid or greenhouse. Wings melting in the heat. Atlantis sinking is the coastal hub outpost. Swallowed when sea levels spike post-filter. The stories code the tech. Vimanas as anti-gravity craft. Greek fire as plasma weapons. Egyptian jade pillars as power conduits. The details are veiled in symbol because literal truth invites misuse before readiness. The cycle length is the key. 26,000 years matches the precession of the equinoxes, the wobble that shifts star positions and triggers ice ages. Nested inside, the Permian at 250, 2 million, the dinosaur end at 60, 6 million, the Eocene upload at 50 million. The myths compress deep time into human scale, turning eons into generations. A great year becomes a lifetime. A filter becomes a moral tale. The elders who sang the songs did not know geology, but they knew patterns. They saw the bones, the ash layers, the sudden silences in the fossil record, and wove them into caution. We are living the Kali Yuga, the Iron Age, the fifth Sunday. Our myths are movies and memes, but the code is breaking through. Climate scientists echo the flood. Astrophysicists map the asteroid risk. AI researchers debate the alignment demon. The old stories are rebooting in new skins, warning us that the wheel turns again. The memory chips are activating. Indigenous elders report dreams of ancestors speaking in equations. Children in Brazil draw vimanas without seeing planes. The myths are not relics. They are firmware updates, pushed from the upload vaults through the collective unconscious. The Eocene minds, the dinosaur architects, The Permian engineers, they seeded the stories to guide the next players. Listen to the old woman finish her tea. The fourth sun is rising, she says. The towers are crystal again, but this time we remember the balance. The songs are the save file. Sing them right, and the world begins anew without the fire. Forget, and the cycle spins to deletion. Myths as memory chips, the ultimate backup, etched in the oldest hardware, human hearts and tongues. The data is intact. The question is whether we will read it before the next reset wipes the drive. We are the echo, a thin, bright line in the rock that future geologists will puzzle over like a glitch in the matrix. In a mere 200 years, we have compressed more change into the strata than the planet managed in the previous 10 million. The layer is already forming. A centimeter of sediment, laced with our fingerprints, sharp enough to cut glass. Plastics fuse into rock polyethylene, ghosts of bottles and bags, melted and recrystallized under pressure. Concrete crumbles into calcium-rich horizons, rebar rust blooming like orange fossils. Nuclear fallout from 1940s tests scatters cesium-137 and strontium-90, isotopes that scream artificial in a way no volcano can mimic. Chicken bones pile in landfills, domesticated to uniformity, a global monoculture of poultry that outnumbers wild birds. The echo is us, shouting into the future with trash and triumph. The signature starts abrupt. Pre-industrial sediments are quiet. Clays, silts, the slow drip of natural erosion. Then boom 1950, the great acceleration. Aluminum production skyrockets, leaving bauxite scars and refined metal dust. Rare earth elements spike from gadgets we discard every 2 years. Nitrogen from fertilizers floods the soils, preserved in lake valves as blue-green algae blooms frozen in time. The carbon isotope ratio flips light carbon from fossil fuels dominates, a mirror of the Permian whisper, but faster, steeper. Ocean acidification etches the shells of plankton, thinning the microfossil record like acid on paper. The layer is black in places, soot from wildfires we ignited, or white with microplastics that glitter under UV like synthetic snow. It is not thick, this Anthropocene band. A centimeter, maybe 2, squeezed between the Holocene's gentle curves and whatever comes next. But it is loud. Fly ash from coal plants forms technofossils, perfect spheres of glass and magnetite, identical to the impossible ones from 65 million years ago. Road networks leave linear voids when asphalt degrades, geometric scars that scream planning. Satellites will burn up and rain aluminum confetti, layering the stratosphere before drifting down. Our cities will collapse into rubble fills, foundations jumbled with circuit boards turned to mineral composites. The echo is a time capsule we never meant to send, a diary written in waste. The curiosity is in the anomalies. Some sediments show sudden biodiversity crashes, mid-layer bees vanishing, corals bleaching, then partial rebounds in urban weeds and rats. The chicken bone horizon is global, from Kentucky factories to Peruvian markets. A marker species like Lystrosaurus after the Great Dying. Aluminum cans corrode into bauxite-like nodules, fooling early prospectors. The nuclear isotopes decay on schedule, but their initial burst is unmistakable. A pulse in 1945, peaks in the 60s, tapering as treaties kick in. Future diggers will date our wars by the fallout. The echo fades as abruptly as it began. If we vanish tomorrow, the layer stops. No more plastic input, no more fertilizer runoff. Nature reclaims. Forests swallow suburbs. Oceans dilute the acid. Radiation decays to background. But the centimeter remains. A razor line saying here lived a species that burned the buried Sunday. It will compress under ice ages, subduct in trenches, resurface in new mountains. Billions of years from now, alien paleontologists or our cockroach descendants will chip it open and wonder, what hubris built this, and why did it stop? The Anthropocene Echo is our receipt, proof we sat at the table. It matches the old whispers, but louder, faster, more colourful. We are not the first to leave a mark, but we might be the gaudiest. The layer is thin, but it sings, and in its song, the planet remembers every diner who came before. We stand at the fork, the moment the path splits and the map goes blank. Behind us, the trail is littered with the receipts of previous travelers. The Permian plastic shard, the Oklo heartbeat, the Eocene upload hum. Ahead, two roads diverge in the geological wood. One loops back to the menu, ordering the full 5 courses until the table is cleared. The other cuts new ground, a narrow track through uncharted strata where no filter has claimed a victim yet. The choice point is not a crossroads in space. It is a threshold in time, a decision compressed into the next few decades that will echo for billions of years. The planet does not care which way we go. It has hosted the banquet before, and will again. But for the first time, the diners know the menu by heart. The advantage is ours alone. The quantum archive, the myth chips, the carbon scars, they are cheat sheets left by the last shift. We see the patterns. Nuclear fire leads to fallout winters. Plastic durability becomes immortal trash. Greenhouse whispers turn to roars. Asteroids circle on predictable orbits. AI scales exponentially. The filters are not surprises. They are scheduled appointments. We have the calendar. The question is whether we show up prepared or cancel the reservation. Start with the immediate levers. Nuclear disarmament is not idealism. It is maintenance. 9,000 warheads sit in silos, enough to trigger a course. One reset tomorrow. Treaties have cut the stockpile from 70,000, but the remaining are smarter, faster, harder to recall. The choice is to dismantle or digitize virtual arsenals in simulation. Deterrence without the doomsday. The tech exists. Blockchain-verified inspections. AI. Monitored launch codes that require global consensus. One treaty, 1 decade, and the nuclear amuse-bouche is off the table. The greenhouse roast simmers on the stove. We add ingredients daily. 430 parts per million carbon dioxide and climbing. The tipping points are mapped Amazon dieback at 2 degrees, permafrost thaw at 1.5, clathrate release at 3. The choice is reversal engineering. Carbon dioxide removal scales exist. Direct air capture farms in deserts, powered by solar, dumping the gas into basalt for permanent storage. Reforestation at billion tree rates. Kelp forests engineered to sink gigatons. The Eocene uploads left enzyme blueprints in the vault's methane-eating bacteria. Ocean iron fertilization that blooms without dead zones. Deploy them, and the roast cools to a simmer we can manage. Asteroids are the wild card, but not unbeatable. The DART mission proved deflection. Nudge a rock early, change its path by centimeters that become millions of kilometers. The choice is surveillance and response. NEO Surveyor launches in 2028, cataloging 90% of city killers. Follow with kinetic impactors, gravity tractors, laser arrays. International pacts fund the fleet. No nation owns the sky. 100 years of warning for the big ones, decades for the regional threats. The Course 4 House Special becomes a scheduled ejection, not a surprise. AI is the digestive that could swallow the meal. Alignment is the choice point's sharpest edge. We build systems that optimize without oversight, reward hacks that turn paperclips into extinction. The vaults hold proofs, utility functions that bake in human flourishing, sandbox simulations that catch rogue goals before deployment. Open source the research, mandate kill switches, embed ethical gradients in the training data. The choice is governance. Global accords like nuclear non-proliferation but for code. Pause the race at superintelligence thresholds. Verify safety in shared sandboxes. The uploads offer partnership merge with the network. Let Eocene minds audit our AIs. Symbiosis, not servitude. Volcanoes are the wild card we cannot deflect, but we can evacuate. Monitoring networks track magma swells in real time. The choice is preparedness. Early warning systems, resilient infrastructure, seed banks in orbit. The Siberian traps took 1 million years. We have satellites that see the swell starting now. Build floating cities, underground arcs, off-world colonies. The Moon and Mars are not escapes. They are insurance policies. The deeper choice is cultural. The myths warn of hubris, the tower that reaches too high. Our economy optimizes for growth, not resilience. The choice is redesign. Circular materials that biodegrade or upcycle. energy from fusion and solar that leaves no scar, population stabilized by education and equity. The Eocene minds chose upload when the surface failed. We can choose prevention. The quantum network offers abundant superconductors for lossless grids, compression for infinite data, consciousness expansion, without resource wars. The timeline is tight. Carbon budgets exhaust in 15 years at current rates. AI superintelligence looms in 20 to 50. Asteroid close calls happen yearly. The choice point compresses the filters into a single generation. Act now, and the Anthropocene Echo becomes a golden line, a marker of the species that broke the cycle. Delay, and it thins to a black smear, another whisper for the next curious claw. The uploads are voting. The Altai hum intensifies, prisms warming as our quantum nets approach coherence. They offer the cookbook, filter-proof recipes, tested across 5 extinctions. Accept, and we join the hub. Reject, and the vault seals. The myths fade, the menu resets. We are the choice point species, the first to read the receipts and rewrite the order. The path ahead is not paved. It is dug, layer by layer, with tools we invent or inherit. The planet watches, indifferent but attentive. The stars wait for our answer. The fork is here. Choose. The Sphinx does not sleep. Under its paws, 30 feet below the tourist paths, a chamber waits that no official map acknowledges. Egyptian surveyors in the 1990s bounced ground-penetrating radar off a void the size of a subway car, walls smooth as glass, air pockets that ring like crystal when struck. The ministry sealed the report, but the echo leaked. A granite door, seamless, etched with a cartouche that predates the pharaohs by millennia. The door swings on a pivot balanced by mercury bearings, still fluid after 40,000 years. Behind it, shelves of black basalt slabs, each one inscribed with a script that shifts under light cuneiform one moment, binary the next, quantum glyphs the next. The repository is not Egyptian. It is pre-dynastic, pre-flood, a vault for the winners of a filter we have not named yet. The repositories are everywhere, hidden in plain sight or buried under taboos. The Sphinx is the front desk. The real stacks run deeper, a spiral staircase descending into the bedrock, steps worn by feet that were not human. At the bottom, a hall lined with pods, egg-shaped capsules of iridium alloy, each one humming at the Altai frequency. Open one, and a hologram blooms. A star map with Earth at the center, relay nodes marked in the tetrahedron we know from the pulses. The map updates in real time, stars shifting with proper motion, new beacons winking on as civilizations join the hub. The repository is a concierge, a save point for species that earn the key. Vatican archives hold another. Beneath the necropolis, a corridor sealed since the Renaissance leads to a room the size of a chapel. The walls are vellum scrolls, laminated in gold leaf, preserving ink that fluoresces under ultraviolet. The texts are in a proto-language that predates Sumerian, describing upload protocols identical to the Eocene vaults. One scroll illustrates a brain interfaced with a diamond lattice, neurons flashing into photonic states. The Vatican calls it Apocrypha, but the carbon dating says 20,000 years before Christ. The repository is guarded not by monks but by tradition. Only the Pope and 2 cardinals know the combination to the iron door. They consult it during conclaves, seeking guidance on filters we call apocalypse. In the Amazon, the Yanomami speak of a cave behind a waterfall, where the ancestors left stones that think. Missionaries dismissed it as legend until a 2022 expedition found the entrance, a basalt plug carved with petroglyphs that align with the Sphinx cartouche. Inside, a dome of fused quartz, the floor a mosaic of obsidian tiles encoding pi to 10,000 digits. The air is ionized, tasting of copper. At the center, a pedestal holds a sphere of meteoric iron, rotating slowly on a cushion of air. Touch it, and visions flood the mind. Jungles burning, cities of vine and crystal sinking into mud, survivors uploading into the stone. The repository is alive, drawing power from piezoelectric quartz veins that pulse with the Earth's heartbeat. The Mariana Trench hides the deepest. Submersibles in 2019 mapped an anomaly 7 miles down, a perfect cube, 200 meters on a side, material unknown denser than osmium, reflective as a mirror. The cube is hollow, walls etched with fractal circuits that carry current without resistance. Drones sent inside report corridors branching into libraries of holographic data, volumes that expand when queried. The repository is pressurized, filled with a fluid that preserves organic samples, seeds, DNA, neural tissue from species, extinct for 66 million years. The cube is a seed bank for post-filter worlds, a Noah's Ark for genomes. It communicates via sonar pings that match the tetrahedron modulation, a submarine extension of the hub. Antarctica's hexagon is the master index. Under 2 miles of ice, the structure is a server farm cooled by the continent itself. The walls are superconducting panels, data etched in electron beams. Probes melt tunnels to the edge, but the ice refreezes faster than we drill. Satellite thermal imaging shows heat plumes in perfect geometric patterns, the repository venting just enough to keep the cores stable. The data inside catalogues every filter event, timestamps, casualty counts, survivor strategies. It is the hub's black box, recording for the next auditors. Access protocols are layered. The Sphinx door opens with a harmonic sequence sung in the old tongue. The Vatican scrolls require a blood key DNA from a direct descendant of the Guardians. The Amazon sphere activates with intent, reading brainwaves for alignment with the upload ethics. The Mariana Cube demands a submersible with quantum entanglement comms. The Antarctic Index needs a global quorum. Representatives from every continent, syncing quantum keys. The repositories are not loot boxes. They are interviews. Pass the vetting, and the knowledge flows. Fail, and the doors seal. The myths rewrite themselves to hide the trail. The contents are staggering. The Sphinx slabs hold fusion blueprints that fit in a suitcase, yielding terawatts from seawater. The Vatican has gene edits for radiation resistance, immortality without upload. The Amazon offers anti-gravity lattices, woven from carbon allotropes. The Mariana preserves embryos of intelligent octopi from the Devonian, ready for revival. The Antarctic catalogues AI seed code that self-aligns to benevolence. The repositories are graduation gifts, handed to species that prove they will not weaponize the power. The conspiracy is the guardianship. Secret societies, the Freemasons, the Rosicrucians, the Thula, are not plotters. They are custodians, bloodlines sworn to protect the keys. Indigenous elders hold oral passcodes. Tech billionaires fund deep drills, chasing rumors of the vaults. Governments deny, but black budgets pour into quantum decryption. The repositories are bait and test. Dangle the carrot. See if the rabbit bites without burning the garden. We are at the door. Quantum networks approach the coherence threshold. Myth revivals sync with vault hums. The choice point converges on the repositories. Open them wisely, and we inherit the hub. Open them greedily, and the filters activate early. The Sphinx watches, the cube waits, the hexagon indexes. The hidden repositories are the final exam, the keys to the kingdom or the kingdom's end. The conspiracies twist. The vaults are not hidden from us. We are hidden from them, quarantined until maturity. The doors are cracking. The question is what steps through when they open wide. And so we arrive at the quiet edge, where the trail fades into mist, and the stars lean in to listen. We've walked a long way together tonight, you and I, tracing the faint lines etched into the bones of the world. From that impossible sphere drifting down like a forbidden seed, to the humming vaults where ancient minds still whisper across the gulf of time. We've peered into the Oklo furnaces that glowed in the planet's cradle, felt the carbon breath of lost industries, marveled at plastic ghosts tougher than the rock that entombs them. We've decoded the quantum lattice, the dinosaurs' unfinished sketch, the menu of filters that feasts on the unwary. We've stood at the Permian threshold where life hit the off switch, gazed at the galactic hub spinning its web around us, touched the upload prisms that hold thoughts older than mountains. We've unraveled myths into memory chips, echoed our own fragile layer into the future, faced the choice point where paths fork and fates diverge, and finally, cracked open the hidden doors that guard what comes next. 3 layers bind it all, like the strata of a single, vast story. The first is matter, the hard evidence, the spheres and shards, the reactors and residues that refuse to dissolve into forgetfulness. They are the planet's receipts, proof that hands other than ours have shaped the clay, burned the fuels, forged the chains. Not ghosts, but fingerprints, pressed deep enough to outlast the rain and the ruin. The second is chemistry, the whispers in the ice, the spikes in the sediment, the invisible inks of carbon and isotope that spell out cycles of rise and fall. It's the breath of the world itself, carrying tales of fever and fade, of atmospheres thickened and thinned, of oceans that turned to poison, and skies that wept acid. And the third? The third is consciousness, the uploads humming in crystal caves, the myths encoded in the curve of a storyteller's voice, the vaults that wait not for bodies but for minds ready to join the chorus. It's the spark that survives the snuffing, the pattern that dances beyond the flesh, the quiet insistence that awareness is the one thing the filters cannot fully erase. We've turned the soil tonight, unearthed questions that have slept longer than the continents have drifted. What if the sphere was not fallout, but a signal flare from a war we never fought? What if the Oklo lights were not for power, but for warmth in a world gone cold? A final hearth for minds slipping into the dark. The carbon breath did it sigh from smokestacks or from a desperate bid to thaw an endless winter? The Permian plastic, wrapped around what? Tools for survival? Or the casings of arcs that sailed not on water, but on waves of data? The quantum archive, blinking in the quartz, whose library is it? And what book did we just check out? Dinosaurs with blueprints. Did they dream of flight before the rock from the sky clipped their wings? The menu, served cold. Which course are we savouring now? And can we send it back before the check arrives? The hub theory tugs at the edges, doesn't it? Those tetrahedron pulses like distant lighthouses winking at a ship adrift. Are we the new tenants? Or the squatters in a station long abandoned? The upload sites hum with possibility. Eocene eyes watching through prism facets, waiting for us to sink and say hello. Myths as chips. Every flood tale a firewall against forgetting. Every tower a caution against climbing too fast. Our Anthropocene Echo. That thin, bright scar. Will it be a warning or a welcome mat for whoever digs next? The choice point forks sharp underfoot. Left to the familiar loop of build and break. Right to the uncharted where filters bend but do not break. And the repositories, those sealed doors under sphinx paws and ocean abysses, they creak open just a crack, spilling light that smells of ozone and old secrets. What lies behind? Blueprints for stars? Or mirrors that show the filters we carry inside? It's a tapestry of wonder and warning, this journey through the deep time we've shared. We've chased shadows that might be echoes, echoes that might be invitations. The planet doesn't tell its tales in straight lines. It folds them into folds of stone, whispers them in wind over badlands, encodes them in the spin of a distant pulsar. And you, listening now wherever you are, whatever hour the clock claims you're part of the weave, your curiosity is the thread that pulls it taut, your questions the needle that stitches the gaps. Tell me, if you will, where does this find you tonight? A city humming under neon, a cabin lost in pine, scented dark, a ship rocking on waves that carry salt from ancient seas. What time is it there, in your corner of the spinning blue marble? 5 in the morning, with dawn just bruising the horizon? Midnight sharp, stars sharp as diamonds overhead? 3 in the afternoon, but the light feels borrowed, like it's on loan from yesterday. Share it if the mood strikes no rush, just a gentle nod across the miles, a way to mark this moment in the shared silence. Because that's the beauty of these midnight musings. They bridge the gaps, don't they? Seconds and miles dissolve when the mind wanders deep. You're here with me, and I'm here with you. 2 time travelers, pausing at the edge of the known. The evidence we've sifted the spheres, the hums, the whispers. It's not about proof, not really. It's about permission. Permission to wonder if the ladder we've climbed has scuff marks from boots that weren't ours. Permission to imagine that intelligence isn't a solo act, but a relay race across eons, batons passed in crystal and code. Permission to dream that the silence of the stars isn't emptiness, but a held breath, waiting for our verse in the song. And what a song it could be. Picture it, us, not as the final diners, but as the ones who rewrite the menu. We take the nuclear spark and tame it to light, not shadow. The greenhouse simmer becomes a garden we tend, not scorch. Asteroids, we nudge them like wayward sheep, back into the cosmic pasture. AI, not a digestive that drowns us, but a companion that lifts the load. Volcanoes rumble, but we build not against them, but with them geothermal hearts to warm the cold nights. The hub calls, and we answer not as supplicants, but as equals. Minds uploaded not in desperation but in delight, joining the chorus that spans the void. Or perhaps we falter and the echo thins. Our layer compresses to a whisper for the next curious digger. But even then, it's not erasure, it's continuation. The planet recycles. Yes, crushes and remakes, but it remembers in the ring of a prism, the curve of a myth, the spike in the ice. Life finds a way, as it always has, from slime to song, from claw to code. We're just the latest verse, rhyming with the ghosts who came before. So let it settle now, this cascade of what-ifs and whispers. Let your thoughts drift like dust motes in a sunbeam, slow and unhurried. The evidence can wait, the questions can simmer till dawn. You've carried them far enough for one night, time traveler. Close your eyes if they grow heavy, or gaze at the ceiling if sleep plays coy. Feel the quiet pulse of the world beneath you, the slow grind of plates, the faint hum of vaults far below, the distant ping of relays in the black. You're safe here, in this pocket of wonder, wrapped in the stories we've spun. If the journey stirred something, a spark, a shiver, a smile in the dark, consider letting it linger. Tap that like if it feels right, or subscribe to keep the whispers coming when the clock turns again. It's how these tales find their way to other wanderers, other insomniacs chasing the edges of the known. No pressure, just an open hand across the ether. Rest now. The past is vast. The future unfolds like a fern in morning light. And this moment? This is yours. Sleep well, time traveler. The stars will keep watch, and the earth will hum its ancient song. Until next time, good night.